Welcome to the Master Course, Introduction to Web Security Testing with Burp Suite. We will begin with Module 1, First Steps with Burp Suite, the Digital Interceptor. This module introduces the core concept of Burp Suite as a web proxy, explaining what it is, why it's essential for web security testing, and guiding you through the complete setup and initial configuration.
Lesson 1.1. What is Burp Suite? The digital post office. Let's set the context. Imagine you send a letter to a friend. Normally, it goes straight from the post box to their mailbox. Now, imagine you had a special post office in the middle that could stop every letter you send, allow you to read it, change the message, and then send it on its way. In the digital world, web browsers and web servers are constantly sending these letters, called HTTP requests, back and forth. Burp Suite is that special post office. By the end of this lesson, you will be able to define what a web proxy is and explain Burp Suite's primary role as an essential tool for security testing. We will cover the basic idea of how the web works, introduce the concept of a proxy, and establish exactly where Burp Suite fits into the picture. So, what is an HTTP request? The web runs on a simple request and response model. Your browser requests a web page from a server, and the server responds with the data. This communication happens using a protocol called HTTP. A proxy is simply a middleman. Instead of your browser talking directly to the web server, it talks to the proxy. The proxy then talks to the server on your behalf. Burp Suite is a powerful web proxy built specifically for security professionals. Its primary function is to first, intercept, which means to stop requests and responses before they reach their destination. Second, to inspect, which is to see the exact contents of the communication. And third, to modify, which means to change the data being sent or received to test how the server reacts. This is the core of hacking, testing for weaknesses by sending unexpected data. Let's walk through a practical example. Imagine you are on a test e-commerce site and add a $10 gadget to your shopping cart. You want to see if the website trusts the price sent from your browser. With Burp running, you turn Intercept on. You click the Proceed to Checkout button. Burp's Intercept tab freezes the request, and you see a line like, and product ID equals 42, and quantity equals 1, and price equals 10.00. You manually change the value from $10 to $1. You then click Forward to send the modified request. The checkout page loads and shows your item now costs only $1. This is a basic vulnerability, but it perfectly demonstrates Burp's power. You saw and changed data that is normally invisible. Now for an interactive thought experiment. Think about a social media profile page where you can update your hometown. When you type in New York and click Save, a request is sent. If you could intercept that request with Burp, what other information might you see being sent? Could you see your user ID, your email? This exercise trains you to think about hidden data. Finally, a quick assessment. The prompt is, in 1 or 2 sentences, explain to a non-technical friend what Burp Suite does using the digital post office analogy. The solution is, Burp Suite acts like a special post office for my internet traffic. It lets me pause any letter my browser sends to a website, read what's inside, and even change the message before it continues to its destination. This is useful for finding security flaws.
Lesson 1.2. Setting up your lab, the workshop. A mechanic can't fix a car without a garage and the right tools. Similarly, a security tester needs a properly configured lab. In this lesson, we will build our workshop. Our objective is to install Burp Suite Community Edition and configure a web browser to correctly route its traffic through the Burp proxy, including handling HTTPS traffic. We will walk through downloading Burp Suite, configuring your browser's proxy settings, and installing the critical Burp CA certificate. First, download the free Community Edition from the official PortSwigger website. Second, your browser needs to be told to send its traffic to Burp Suite, which listens on address 127.0.0.1:8080. Using a browser extension like Foxy Proxy makes turning this on and off simple. Third, most websites use encrypted HTTPS. When Burp intercepts this, your browser will show an error because it doesn't trust Burp. To fix this, you must install Burp's CA certificate, which tells your browser to trust Burp. Here's a practical example. Imagine you have installed Burp and set up your browser's proxy. You try to visit https://google.com, but your browser shows an error page saying your connection is not private. This error is happening because the browser doesn't recognize the certificate presented by Burp. To fix this, with your proxy on, you navigate to the special address http://Burp Suite. On this page, you click the CA certificate button to download the certificate file. You then go into your browser's settings for managing certificates, find the Authorities tab, and import the file you just downloaded, making sure to trust it for identifying websites. After this, you can refresh the https://google.com page, and it will now load perfectly. You have successfully configured your lab. For an activity, follow this checklist. Download and install Burp Suite Community Edition, install the Foxy Proxy extension and configure it for Burp. Start Burp and activate the proxy profile. Navigate to http://Burp Suite and download the CA certificate. Import the certificate into your browser's trusted authorities list. Finally, test your setup by visiting any HTTPS website. Now for the assessment. The prompt is, a colleague has set up Burp Suite, but complains that every time they visit a site like https://google.com, they get a big security error. What did they likely forget to do? The solution is, they almost certainly forgot to install the Burp CA certificate into their browser. Without it, the browser doesn't trust Burp's interception of encrypted HTTPS traffic.
Lesson 1.3. The Proxy tab, your control center. Your digital post office is now running. The Proxy tab is the main sorting room. Our objective is to differentiate between the Intercept and HTTP history subtabs and describe the function of the forward and drop buttons. The Intercept subtab is your pause button. When Intercept is on, every request is paused, waiting for you to forward, which means send, or drop, which means discard. When Intercept is off, traffic flows freely but is still recorded. The HTTP history subtab is your complete logbook. It contains a record of every request and response that has passed through the proxy. A common and efficient workflow is to keep Intercept off while browsing. This populates your HTTP history. You can then look through the history to find interesting requests and send them to other Burp tools. For a practical example, imagine you are testing a website search function. You want to analyze the search request, but the page also loads 50 other items, like images and ads. You don't want to click forward 50 times. To handle this, you ensure Intercept is off. In your browser, you type your search and hit Enter. The results page loads normally. You then switch to Burp's HTTP History tab. You will see a long list of requests, but you can quickly sort and find the one that looks like get/search, query equals my test search. You have successfully isolated the exact network request without getting bogged down by irrelevant traffic. Here is an interactive activity. Turn Intercept on. Visit http://example.com. Observe the request caught in Burp and click forward until the page loads. Now turn Intercept off and visit a different website. Go to the HTTP History tab. Can you find the requests for both websites you visited? And the assessment. Prompt. You want to log in to a web application and examine the specific login request, but you don't want to click forward for every single file. How would you accomplish this? Solution. The best method is to turn Intercept off first, then log into the application normally. Afterward, go to the HTTP History tab, which has recorded all the traffic, and locate the specific login request to analyze it there. This concludes Module 1. You have successfully set up your lab and understand the fundamental concept of intercepting and viewing web traffic. Let's proceed with Module 2.
core tools for mapping and analysis. Now that you can intercept traffic, it's time to understand the application you're testing. This module covers the tools Burp uses to create a map of the target website, discover its pages, and find low-hanging fruit. Lesson 2.1: The Target tab, or your blueprint. Imagine you're a building inspector arriving at a new skyscraper. Before checking individual rooms, you'd want the building's blueprint. The Target tab in Burp Suite is your application's blueprint. Our objective is to describe the purpose of the sitemap feature and explain how to define a scope for your testing. As you browse your target application, Burp automatically builds a tree-like structure of the site in the Target Sitemap tab. This gives you an immediate overview of the application's size and complexity. Scope is how you tell Burp to only show and test things related to your target website. In the sitemap, you simply right-click the main entry for your target and choose Add to Scope. You can then use the filter bar to show only in-scope items. For example, you are testing ginandjuice.shop. Your sitemap also contains entries for googleanalytics.com, which is clutter. To fix this, you navigate to ginandjuice.shop in your browser. In Burp's Target tab, you right-click https://ginandjuice.shop and select Add to Scope. Then you use the filter bar to show only in-scope items. The sitemap instantly cleans up, showing you only the structure of your target. Here is an activity. With Burp running, browse 2 or 3 different websites. Go to the Target tab and observe how Burp has organized them. Right-click on one and Add to Scope. Use the filter to show only in-scope items, then turn it off again to see everything. Assessment prompt. Why is setting a scope one of the most important first steps in any testing engagement? Solution. Setting a scope is crucial because it focuses your tools on the target application. It prevents you from accidentally testing third-party services and reduces noise, making your findings cleaner and more organized. Lesson 2.2: The Spider, your robot explorer. You have the blueprint, but only for the floors you've walked on. The Burp Spider is a robot explorer that automatically follows every link it finds, adding everything to your sitemap. Our objective is to explain the function of the Burp Spider and differentiate it from manual browsing. Spidering is the automated process of following links to discover new content. The spider starts from a target, reads the HTML, finds all the links, and then visits each of those links, repeating the process. It's useful because a manual browse might miss things, like old admin portals or forgotten test pages. Here's a practical example. You are testing ginandjuice.shop and have browsed a few pages. To find more, you add the site to your scope. Then, in the Target tab, you right-click on https://ginandjuice.shop and select Spider this host. You can then watch your sitemap as new items are automatically discovered and added to the blueprint. The spider might discover a page called /admin_login_old.php that wasn't linked anywhere on the main site, which is a perfect candidate for testing. For an activity, use a vulnerable practice application, add it to your scope, and browse only 1 or 2 pages manually. Note the size of your sitemap. Now, spider the host, return to your sitemap, and see how many new pages the spider found compared to your manual browsing. Assessment prompt. What is the main advantage of using the spider over just clicking every link on a website yourself? The solution. The main advantage is efficiency and thoroughness. The spider automates discovery, ensuring it methodically finds all linked content, including forgotten pages that a human might easily miss.
Lesson 2.3: The Scanner, your automated inspector. Your robot explorer has mapped the building. Now you can deploy smaller robots to automatically inspect every room. The Burp Scanner is that team of automated inspectors. Our objective is to define the purpose of Burp Scanner and differentiate between passive and active scanning. Burp Scanner automatically tests for a huge list of common security flaws. Passive scanning, which is available in the Community Edition, is the safe mode. Burp passively analyzes normal requests and responses as you browse, without sending new or dangerous requests. It's like an inspector who just looks around. Active scanning, a pro feature, is the aggressive mode. Burp actively sends new, specially crafted requests to confirm vulnerabilities. It is far more powerful, but must only be used on systems you have explicit permission to test. As a practical example, while you browse ginandjuice.shop, Burp's passive scanner runs in the background. Suddenly, on the main dashboard, a new issue appears. Medium, cross-domain referrer leakage. You click on it, and Burp provides a detailed description of the vulnerability, showing the exact request and response where it happened. Without sending a single malicious request, the passive scanner has already identified a security flaw. Here's an activity. Clear your sitemap in Burp. Browse a web application. Go to the Dashboard tab. In the Issue Activity panel, do you see any issues found by the passive scanner? Click on one and read the detailed description. Assessment prompt. What is the key difference between a passive scan and an active scan in Burp? Solution. A passive scan only analyzes existing traffic without sending new requests. It's safe. An active scan sends new, potentially malicious requests to confirm vulnerabilities. It is far more powerful, but must only be used on systems you have explicit permission to test.
This concludes Module 2. Let's move to Module 3, Core Manual Testing Tools. Automated tools are good, but a real hacker's skill comes from manual testing. This module introduces the key tools that give you granular control.
Lesson 3.1, The Repeater, your science lab. Imagine you've intercepted an interesting HTTP request. You need a lab where you can edit and resend that single request over and over. Burp Repeater is that science lab. Our objective is to explain how to use Repeater to modify and resend a single HTTP request and analyze the response. Repeater lets you take any request from Burp, modify it, and send it. When the server replies, you see the response right next to your request. The workflow is simple. Find a request in your proxy history, right-click, and send to Repeater. Go to the Repeater tab, modify the request on the left, click Send, and see the response on the right. This allows for rapid, precise testing. Practical example. You are testing a user profile page, /profile, user ID equals 123. You wonder what happens if you change the user ID. You send this request to Repeater. In the Repeater tab, you first send the original request to confirm you get your own profile data. Now you change user ID equals 123 to user ID equals 124 and click Send again. In the response pane, you see the profile information for user 124. You have just found a major security flaw using Repeater. For an activity, find a search request in your proxy history. Send it to Repeater. Send it once to see the original results. Now change the search query and send it again. Look at the response to see if it reflects your new search term. Assessment prompt. When would you use Repeater instead of just resubmitting a form in your web browser? Solution. You would use Repeater when you want to make small, precise changes to a single request and immediately see the raw response without the browser reloading a full page. It's much faster and gives you more control.
Lesson 3.2, The Intruder, Your Robot Army. You've used Repeater to test one change, but what if you need to test 10,000 changes, like trying every password in a dictionary? Burp Intruder is your robot army, built to send thousands of slightly different requests automatically. Our objective is to describe the basic concept of a burp intruder attack by identifying payload positions and selecting a simple payload list. The core concept involves positions and payloads. You start with a base request. You mark one or more positions where you want to insert data. Then you provide a list of payloads, words or numbers, that Intruder will place into those positions. The sniper attack type is the simplest. It uses one payload set and targets one position, iterating through your payload list one by one. You then analyze the results table looking for unusual response lengths or status codes. Here's a practical example of a brute force attack. You want to test if the username admin has a weak password. You capture a login attempt and send it to Intruder. In the Positions tab, you mark only the password value as a position. In the Payloads tab, you add a simple list of common passwords like password 123456 and QWERTY. You start the attack. A new window opens. 3 of the requests have a response length of 2,500 bytes, but one has a response length of 5,800 bytes. This difference strongly suggests you found the correct password. For your activity, use a test website with a document viewer like view.php $doc equals 1.txt. Send this to Intruder. Mark the number 1 as the position. For the payload, select numbers from 1 to 20. Run the attack and look at the results. Do any of the responses have a different status code or length? Assessment prompt. What is the fundamental difference between Burp Repeater and Burp Intruder? Solution. Repeater is a manual tool for sending a single modified request at a time. Intruder is an automated tool for sending thousands of requests based on a template where parts of the request are systematically replaced with values from a payload list.
Lesson 3.3: The Decoder and Comparer. Sometimes the data you intercept is encoded. Decoder is your tool for translating this data. Comparer is your tool for finding tiny differences between two similar pieces of text. Our objective is to describe the function of Burp Decoder for encoding and decoding data, and Burp Comparer for identifying differences. Burp Decoder transforms data from one format to another, such as URL encoding or base64 encoding. You paste text in, select an encoding or decoding option, and see the result. Burp Comparer visually compares two pieces of text and highlights the differences. You load two pieces of data, choose to compare by words or bytes, and Comparer highlights any changes. Here are 2 practical examples. For decoder, you intercept a cookie with the value C290MESECRETDATA. You take this to the Decoder tab, paste it in, and select Decode as base64. The text Some Secret Data appears. For Comparer, you have 2 responses from Intruder with nearly the same length. You send both to Comparer. You run a word comparison, and it highlights that the only difference is one response contains Welcome Admin, while the other says Invalid User. For your interactive activities, in Decoder, type a phrase like This is a test, encode it as a URL, then copy the result and decode it back to the original. In Comparer, copy a paragraph of text into both boxes, delete a few words from the second box, and run a comparison to see the changes. Assessment prompt. You test a login form with a correct and incorrect password. The 2 responses look identical in your browser. How could Burp Comparer help you? Solution. Burp Comparer could find subtle, invisible differences. It might reveal a hidden HTML comment, a slight change in a JavaScript variable, or a different cookie being set, which would indicate whether the login was successful or not.
This completes Module 3. Now, for Module 4, Advanced Tools and Extending Burp. This module provides a glimpse into some of Burp's more specialized tools. This completes Module 3. Now, for Module 4, Advanced Tools and Extending Burp. This module provides a glimpse into some of Burp's more specialized tools.
Lesson 4.1: The Sequencer, your predictability tester. When you log in, a website gives you a session cookie.
which should be a long, random, unpredictable string. If it's not random, an attacker could guess it. Burp Sequencer is a specialized tool for testing the quality of this randomness. Our objective is to explain the purpose of Burp Sequencer in analyzing the randomness of data tokens. Randomness is critical for session tokens, password reset tokens, and more. Sequencer works by collecting a large sample of tokens from the server. It does this by resending a request that generates a token hundreds or thousands of times. It then performs a battery of statistical tests on this sample to measure how random the tokens are. The key result is the overall quality of randomness measured in bits of effective entropy. A higher number is better. Practical example. You log in to ginandjuice.shop and receive a session ID cookie. You want to test if it's random. In your proxy history, you find the login request where the server first gave you the cookie. You right-click and send to Sequencer. In the Sequencer tab, you tell it to capture the session ID cookie and click Start Live Capture. After collecting a few hundred tokens, you pause and click Analyze Now. The report states that the tokens have an excellent quality of randomness with approximately 128 bits of entropy. You can be confident they are not guessable. Here is a thought experiment. A website generates password reset links like reset token equals 1, then token equals 2, then token equals 3. Why is this bad? What would an attacker do? This solidifies why randomness is important. Assessment prompt. What is the primary security risk that Burp Sequencer is designed to detect? Solution. Burp Sequencer is designed to detect predictable tokens. The primary risk is that if critical tokens are not truly random, an attacker can guess a valid token for another user, leading to session hijacking or account takeover.
Lesson 4.2. Extending Burp. The App Store. Your smartphone becomes powerful when you install apps. Burp Suite is the same. You can add new features by installing extensions from the App Store. Our objective is to describe the function of the App Store and explain how extensions can enhance Burp's functionality. The Extender tab is the command center. It contains the App Store, a marketplace where you can install extensions written by the security community. Extensions can do almost anything: add new scanner checks, improve workflow, visualize data, or integrate with other tools. Popular extensions include Logger++ for a better history view and JSON Web Tokens for handling a common token type. Practical example. You are testing an application that uses a lot of JavaScript, and the default sitemap is missing pages. You go to the Extender App Store, search for an extension like JS Link Finder, and click Install. Now, as you browse the site, this extension will automatically parse JavaScript files for hidden links and add them to your sitemap, significantly upgrading Burp's ability to handle modern web apps. For your activity, go to the App Store in Burp. Don't install anything yet, just browse. Find the Logger++ extension and read its description. Then find the Authorize extension and read its description to get a feel for what's available. Assessment prompt. Why would a security tester want to use the App Store? Solution. A security tester would use the App Store to customize and enhance Burp Suite's capabilities. It allows them to add new features, improve their workflow, and tailor Burp to the specific application they are testing.
This concludes Module 4. We'll now begin finding vulnerabilities in Module 5, Foundational Web Attacks Part 1. This module covers common attacks related to authentication and session management.
Lesson 5.1. Brute Force Attacks. Trying every key. Imagine a lock with a 4-digit PIN. You could try every combination from 0000 to 9999. This is a brute force attack. We apply the same logic to login forms. Our objective is to use Burp Intruder to configure a simple brute force attack against a login form. The target is usually a login page, and the goal is to guess a password for a known username. Burp Intruder is the perfect tool. The list of passwords you try is called a word list. To identify success, you look for anomalies in the intruder results, like a different status code or a different response length. Practical example. You are testing ginimjuice.shop and know the username is admin. You capture a login request and send it to Intruder. You set a position marker only on the password value. For payloads, you provide a short list of common passwords. You start the attack. In the results, you see that most attempts have a response length of 1,540 bytes, but one attempt has a length of 3,820 bytes. This significant difference indicates you have successfully guessed the password. Here is a thought experiment. What are some ways a website could defend against a brute force attack? Think about what happens on your banking website if you get your password wrong too many times. Assessment prompt. When analyzing the results of a brute force attack in Intruder, what are the two main indicators you look for to spot a success? Solution. The two main indicators are a difference in the HTTP response length and a difference in the HTTP status code.
Lesson 5.2: Cookie Tampering and Weak Sessions. Forging your ID badge. When you log in, a website gives your browser a cookie, which is like a digital ID badge. What if this badge just said isAdmin equals false? Could you change it to isAdmin equals true? This lesson explores attacking cookies. Our objective is to use Burp Repeater to modify cookie values to test for vulnerabilities. A vulnerability occurs when a website stores important information in a cookie and trusts the value that comes back from the user. Look for cookies with meaningful names or decipherable values. A bad, potentially vulnerable cookie might be user_role equals guest, or a base 64 string that decodes to user equals Bob, admin equals false. Burp Repeater is perfect for testing this. Practical example. You log into ginandjuice.shop. You see a cookie user_data equals followed by a long string. You take this string to decoder and decode it from base 64. It reveals the text username tester is admin false. This is a huge red flag. You send a request to your account page to Repeater. You modify the isAdmin value from false to true. You re-encode this new string back into base 64. You replace the original cookie value in Repeater with this new one and click Send. The response now contains a link to the admin panel. You have successfully escalated your privileges. For an activity, log into a test application. Find its session cookie. Send a request with that cookie to Repeater. Now try deleting the cookie entirely and send the request. What happens? Now try changing just one character in the cookie. What happens now? Assessment prompt. What is the fundamental design flaw that leads to cookie tampering vulnerabilities? Solution. The flaw is that the application stores sensitive data on the client side, in the cookie, and then trusts that data when it's sent back. Security-critical decisions should always be based on data stored securely on the server.
Lesson 5.3: Bypassing 2FA and Identifying Weak Sessions. Two-factor authentication, or 2FA, is a critical security layer. But if implemented incorrectly, it can be bypassed. Our objective is to describe a common logical flaw in 2FA implementation that allows a bypass. The correct workflow is: user submits password, server validates and flags session as logged in but not verified, user submits 2FA code, server validates and elevates session to fully verified. A common flaw is that the application doesn't restrict the user to only the 2FA page while they are in that intermediate state. The bypass is simple. An attacker logs in with a password. They are sent to the 2FA page. Instead of entering a code, they simply browse directly to an internal page, like /myaccount. If the server only checks if they are logged in and not fully verified, it might grant them access. Practical example. You have the username and password for a user on ginandjuice.shop. You log in. The site redirects you to /enter 2FA code. Instead of entering a code, you manually change the URL in your browser's address bar to https://ginandjuice.shop/myaccount and press enter. The My Account page loads successfully. The server failed to enforce the 2FA check on subsequent requests. Here's a thought experiment. A website requires 2FA, but it lets you browse to the /change password page before you enter your 2FA code. Why is this a critical vulnerability? Assessment prompt. Describe the logical flaw that allows this 2FA bypass. Solution. The logical flaw is a failure of the application to properly enforce an intermediate pending 2FA state. It fails to check if the 2FA step has been completed before granting access to other authenticated pages.
This completes Module 5. Let's continue with Module 6, Foundational Web Attacks, Part 2, HTTP Manipulation. This module focuses on vulnerabilities that arise from manipulating the structure of the HTTP protocol itself.
Lesson 6.1. HTTP Verb Tampering, Changing the Intention. An HTTP request has a verb or method that tells the server the user's intention, like get to retrieve data or post to submit data. Some security checks might only be applied to one of these verbs. Our objective is to use Burp Repeater to change the HTTP method of a request to test for bypasses. The vulnerability occurs when a developer writes a security rule for one verb but not another. For example, a rule might say, to access admin, the request must be a post with a valid cookie. An attacker could try sending a GET request instead, and the rule might not apply. Practical example. An admin page at /admin/deleteuser.php !user ID equals 5 is protected. A GET request gives you a 403 forbidden error. You send this request to Repeater. In Repeater, you change the word GET to head. You click Send. The server responds with a 200 OK status. Because a head request has no body, you don't see anything, but the 200 OK indicates success. You check the user list and user 5 has been deleted. The security rule forgot to block head requests. For an activity, find a post request from a login form. Send it to Repeater. Change the verb from post to get, moving the parameters from the request body to the URL. Send the request. Does the server give an error or process the login? Assessment prompt. What is the core developer mistake that leads to HTTP verb tampering vulnerabilities? Solution. The core mistake is implementing security controls that are tied to a specific HTTP method. The developer writes a check for post requests but forgets to apply the same check for other methods like get or head.
Lesson 6.2. HTTP Parameter Pollution, Confusing the Server. Imagine a form with a box for your name. What if you put two names in that box? HTTP Parameter Pollution, or HPP, is the digital equivalent. We send a request with the same parameter name twice, with different values, to see if we can confuse the server. Our objective is to use Burp Repeater to duplicate HTTP parameters to test for unexpected behavior. A normal request might be $from equals attacker and to equals victim and amount equals 10. An HTTP attack would be
from equals attacker, and to equals victim, and amount equals 10, and to equals attacker. How does the server handle the to parameters? Some technologies use the last one, others use the first, and some combine them. This ambiguity can be exploited. Practical example. A password reset function uses the URL reset email equals user@example.com. A firewall blocks you from putting a malicious email in the request, so you try an HTTP attack. You send the request reset email equals user@example.com and email equals attacker@evil.com. The firewall sees the first parameter, email equals user@example.com, thinks it's fine and lets the request pass. But the backend server is built on a technology that uses the last parameter. It ignores the first one and processes email equals attacker@evil.com, sending the user's password reset link to the attacker. For an activity, find a search feature like /search query equals test. Send it to repeater. Pollute it. /search query equals test and query equals books. Send the request. Which term did the website search for? The first, the last, or did it error out? Assessment prompt. What is the fundamental condition that makes an HTTP parameter pollution attack possible? Solution. The fundamental condition is ambiguity. The attack is possible because there is no universal, standardized way for web servers to handle requests containing duplicate parameter names. Different technologies behave differently, and an attacker can exploit this inconsistency.
This brings us to our final technical module, Module 7, Introduction to Injection Attacks. This is one of the most critical and dangerous classes of web vulnerabilities.
Lesson 7.1. The concept of injection, data versus command. Imagine a judge tells a witness, "Please state your name." The witness is supposed to provide data. But what if the witness shouted a command? "Everyone rise!" That's an injection attack. The witness provided a command where the judge was expecting data. Our objective is to differentiate between data context and command context in a web application. An injection vulnerability occurs when an application takes user input and passes it directly to a back-end system without first sanitizing it. Sanitizing means cleaning the data to remove special characters or commands. The type of injection depends on the back-end system. SQL injection targets a database, while command injection targets the server's operating system. Practical example. A website has a feature to look up employee details with the URL /lookup name equals Smith. The code runs the command grep Smith /etc/employees.txt. An attacker visits the URL /lookup name equals Smith ls-la. The server naively combines the strings. The command that now runs is grep Smith ls-ls/etc/employees.txt. The semicolon is a command separator in Linux. The server first runs the grep command, and then it runs the injected ls-la command, listing all files in the current directory. Here is a thought experiment. A website displays "Welcome back" username. The username is stored in a database. If you could inject a command, would it need to be in SQL for the database or JavaScript for the browser that displays the message? Assessment prompt. In your own words, what is the core mistake a developer makes that allows an injection vulnerability? Solution. The core mistake is trusting user input. The developer takes data from a user and passes it directly to a back-end system without cleaning it first, allowing the user to mix commands in with their data.
Lesson 7.2, SQL Injection, Making the Database Talk. Most websites store their data in an SQL database. An SQL injection, or SQLI, attack is when we smuggle our own SQL commands into the queries the website is sending. Our objective is to describe how a malformed input can alter an SQL query to bypass a login. A typical login query looks like this. Select asterisk from users where username equals username and password equals password. Now consider the attacker's input for the username, or 1 equals 1 dash. The server naively builds the query, select asterisk from users where username equals blank, or 1 equals 1 dash and password equals blank. Let's break this down. The first single quote breaks out of the data context. The or 1 equals 1 introduces a new logical condition that is always true. The dash or comment nullifies the rest of the original query, ignoring other conditions like the password check. The database now executes the query. Select all users where the username is empty or 1 equals 1. Since 1 always equals 1, the condition is true for every single row. The password check is ignored, the query returns all users, and the code logs you in as the first user, who is usually the administrator. Practical example. You are on a login page. In the username field, you type or 1 equals 1 dash. In the password field, you type anything. You click Login. You are then redirected to the dashboard, logged in as the admin user. You successfully bypassed authentication. Here's a thought experiment. A search page has a URL, products.php, category equals GIFs. How could you use the or 1 equals 1 dash trick to make the page display all products from all categories? Assessment prompt. Explain what the three parts of the or 1 equals 1 dash payload do to an SQL query. Solution. The initial single quote breaks out of the data context. The or 1 equals 1 introduces a new logical condition that is always true. The dash or comment nullifies the rest of the original query, ignoring other conditions like the password check.
Lesson 7.3, Command Injection, Making the Server Obey. Command injection is even more direct than SQLI. We make the server's operating system run our commands. Our objective is to use Burp Repeater to inject a simple OS command into a vulnerable parameter. These vulnerabilities often appear in functions that provide diagnostic information, like a ping utility. The flaw occurs when the developer concatenates user input directly into a command string. For example, system ping -C4 plus IP address. An attacker can use special characters like the semicolon to separate commands. If they provide the input 8.8.8.8 semicolon who am I, the server will run ping -C4 8.8.8.8 semicolon who am I. It will first ping the IP, and then it will run the who am I command. Practical example, a website has a network tools page. You enter an IP address, 8.8.8.8, and see the ping output. You send this request to Repeater. You find the parameter IP_address equals 8.8.8.8. You change it to IP_address equals 8.8.8.8 semicolon ls. You click Send. The response body first shows the ping output, followed immediately by a listing of all the files in the web server's current directory. You have successfully executed a command on the server. For an activity, a vulnerable application has a URL /docs.php $cmd equals ping. What would you append to the URL to make the server tell you its own IP address? The command on Linux is ifconfig or IPA. Assessment prompt. What is the difference between SQL injection and command injection? Solution. The target is the main difference. In SQL injection, the commands are interpreted by the database server. In command injection, the commands are interpreted by the web server's operating system. Command injection is often more critical as it can give direct control over the server.
Final conclusion and recap. Congratulations on completing the Introduction to Web Security Testing with Burp Suite Master Course. You began in Module 1 by setting up your essential toolkit. In Module 2, you created the blueprint of your target application using the target and spider tools. Module 3 was where you mastered the manual tools: repeater, intruder, decoder, and comparer. In Module 4, you explored advanced tools like sequencer and learned how to extend Burp's capabilities. Finally, in Modules 5, 6, and 7, you put it all into practice. You learned to think like an attacker, performing brute force attacks, cookie tampering, and bypasses. You manipulated the HTTP protocol and learned the devastating power of SQL and command injection. You now possess the foundational knowledge and practical skills to analyze the security of a web application. The journey of a security professional is one of continuous learning. The next steps are to practice these skills on dedicated legal platforms, explore more complex vulnerabilities, and never stop asking, "What happens if I do this?"